All right, and welcome to this live tutorial for trigonometric ratios, and we're going to be jumping right in. So, example 1, for each triangle, write down the length of the opposite, adjacent, and hypotenuse. Well, for trigonometric ratios, we will be focusing mainly on right angle triangles. I have two examples here. And what makes a triangle a right angle triangle? Well, one of the three angles within the triangle is a 90-degree angle, and this 90-degree angle is depicted by this right angle here. So any triangle with this symbol is a right angle triangle, and this angle is 90 degrees. Well, they want us to write down the length of the opposite. So let's just put that down. Opposite. And moving forward, we will give the symbol opposite capital O. And they want us to also put down the adjacent. Also moving forward, we will give the adjacent symbol capital A. And they would also like us to write down the length of the hypotenuse. Moving forward, we will give this variable a symbol of capital H. So opposite O, adjacent A, hypotenuse H. Well, these lengths or these sides of our right angle triangle are determined based on the position of our angle. And in this example, this is X. So if we're looking for the opposite, we're looking for the adjacent, we're looking for the hypotenuse. Well, if we're looking for the opposite and adjacent, it is with respect to this angle X. If we're looking for the hypotenuse, then we will be looking for the position of our right angle triangle. Now, let's see if we can determine the opposite, right? So we're looking for the opposite. Now, what exactly is opposite? Opposite means on the other side, in simpler terms, right? So we're looking for which side of the triangle is opposite the angle. Remember, we are looking with respect to this X right here. So the side that is opposite this X is, draw a nice little arrow here. Let's get that arrow looking better, right? We're looking for the side that is opposite this X, and that is equal to 6 centimeters. So this side here, the 6 cm side, that is opposite the angle. All right. And we are now looking for the side that is adjacent. Now, what does adjacent mean? Adjacent means right next to, or the side that the angle sits on. So if we're looking for right next to, it has to be this 8 cm side, right? So, and of course we can see the angle literally sits on it, right? The adjacent therefore equals to 8 cm. Now, when we're speaking about the hypotenuse, we have to take with respect to our 90-degree angle, and that 90-degree angle, of course, is our right angle, and the side that is opposite the 90-degree angle is our hypotenuse. And in this example here, we can see that that side is our 10 cm side. So our hypotenuse is 10 cm. We could have also used the process of elimination. A triangle has only 3 sides. We have already determined the side that is opposite. We've determined the side that is adjacent, and we're left with the hypotenuse. So the opposite is the 6 cm side. The adjacent is the 8 cm side, and our hypotenuse is our 10 cm side. All right, let's go down to our example below. Let's get this diagram a little higher. All right, so similarly, we will be looking for our opposite, we're looking for our adjacent, and we're looking for our hypotenuse. Well, remember we're saying that if we are looking for our opposite, we need to know where our angle is. And in this example, our angle is this angle X right here, right? So that we're looking for the side that is opposite this angle X. And this is this side here, which is the 1.5 meter side, right? Now we're looking for our adjacent. Well, the adjacent is the side that the angle is right next to, or the side that the angle sits on. So we can see that this is this 2 meter side, so our adjacent is 2 meters. Remember, when we're dealing with our hypotenuse, we need to know where our right angle is. And in this triangle, our right angle is right here. Right? This is our right angle. So the side that is opposite that is 2.5 meters. So our opposite 1.5 meters, our adjacent 2 meters, and our hypotenuse 2.5 meters. So for example 1, they wanted us to identify for each triangle, write down the length of the opposite, adjacent, and hypotenuse, and we're able to do that for each, right? Now before we move on, let's talk a little bit about trig ratios. So trig ratios, of course, are determined by the right angle triangle, and we determine them by using the three sides that we were able to just identify. When I was at school, I learned them using an acronym, and that acronym is SO Ka Toa. And what exactly does it stand for? Well, for the trig ratios, we have sine the angle. In this formula here, our angle is theta, is equal to the opposite over the hypotenuse. Cos the angle is equal to the adjacent over the hypotenuse. And tan the angle is equal to the opposite over the adjacent. And remember, we're talking about the sides here. So the SOHCAHTOA right here, this stands for sine, the trigonometric function sine, the S, O, H, so SOAH, Ka, so we have C, our cos, for our trigonometric function cos, A, the adjacent, and H, the hypotenuse, and Toa, T for tan, trigonometric function tan, O the opposite, and A adjacent. So this is a way that you could remember them. But remember, the more you practice, you're going to remember this as you start practicing. It's going to be like second nature to you, right? And as we go through the examples, you're going to see how we can identify them relatively easily instead of remembering this. Okay? But when we're talking about trig ratios, this is what we're talking about. Sine the angle is equal to the length of the opposite divided by the length of the hypotenuse. Cos the angle is equal to the length of the adjacent divided by the length of the hypotenuse. And tan the angle is equal to the length of the opposite divided by the length of the adjacent. Okay? Let's move on. Alright, so here we have example 2. Right? So find the unknown variable for each triangle. Now example 2 is broken up into different parts. So this is our first part right here. And we have this, of course, right angle triangle. So our right angle is right here, which tells us that this side is the hypotenuse, and we don't know, and we are not sure the length of this hypotenuse, right? So what do we know? Well, we know the angle, and I'm going to use theta here. The angle is 30 degrees. All right. Now, we also know the side that the angle rests on. That side is the adjacent, and that adjacent is 3 cm. And we know that the side that is opposite the angle, that is opposite, and that is equal to x cm. So we have our angle, we know what's adjacent, and we know the opposite. How do we find this side which is opposite? Well, if I recall my acronym, SOHCAHTOA, so we have the sine trig ratio, we have the cos trig ratio, and we have the tan trig ratio, right? So we have the adjacent and opposite. Which trigonometric function do I use? Well, in order for me to use sine, I either need my opposite and my hypotenuse, and I don't have my hypotenuse. So of course that already cancels out cos because I need my hypotenuse for these. If I have my adjacent and hypotenuse, I can use cos. I don't have my hypotenuse, so I'm only left with tan, and I need my opposite and my adjacent, and I see this is exactly what I have. Well, if I put down my trigonometric function, tan, the angle is equal to the opposite, the length of the opposite divided by the length of the adjacent. And then we can now substitute our values in, right? So we have tan of 30 degrees is equal to the length of the opposite, x cm, divided by the length of the adjacent, which is 3 cm. Well, we can simplify this, right? So tan 30 degrees is equal to, we have cm in our numerator and cm in our denominator. This can cancel out. We have x over 3. I'll be moving over here. So I want to find my unknown variable x, right? And in order for me to get x, I need to transpose. Of course, for me to get x on one side, I need to remove 3 in my denominator. And if I'm taking 3 out of my denominator and I'm bringing it on the other side of the equal sign, it becomes a product, right? So I have 3 times tan 30 degrees is equal to x. I can rewrite this equation as x is equal to 3 times tan 30 degrees, right? X is equal to, now this is at the point where you jump into your calculator, your nice scientific calculator. Right, you go into your nice scientific calculator and you look for the trig function tan. So you do 3 times tan 30 degrees. Make sure your calculator is in degrees mode. It won't work in any other mode, right? It is the default mode in most calculators, so you don't necessarily have to worry about that. But if you happen to change it, then just put it back in your degrees mode. Right, so 3 times tan 30 degrees. That is equal to, now we're going to get a long decimal number here. We're going to put down the first, let's put down the first 5 decimal places. So here I got 1.73205, right? And that is cm. But I'm going to put my answer to 3 significant figures, and here moving forward I'm going to put all my answers to 3 significant figures, right? So therefore x is equal to, if I'm doing 3 significant figures, I have a video on that, so you can know how to do significant figures very easily. You can jump there that is equal to 1.73 cm, and we must put that we wrote our number to 3 sig figs, right? So for our unknown variable x, which is the opposite side of the triangle, we found it to be 1.73 cm to 3 significant figures, and that is my answer. Moving on. So we have another example here. We can identify our angle. Our angle is 45 degrees. And what do we see here? Well, we notice that we have a side opposite our hypotenuse. And we know that that side is, well, we have identified, sorry, the side that is opposite our right angle. Sorry about that. So we know that that side is our hypotenuse. So we can see that h is equal to 5 cm. We also see that the side opposite the angle here, right? We have that side is x cm. So O for our opposite is x cm. Well, which trig function should I use? So I can put down my acronym SOHCAHTOA. All right. So in order for me to use sine, I must have my opposite and my hypotenuse, and there we go. I mean, we have both of them already. Let's not waste time ruling out cos and tan. We already know we can use sine because we have our opposite side and our hypotenuse. So sine theta is equal to the length of the opposite divided by the length of our hypotenuse. Sine 45 degrees is equal to the length of the opposite, which is x cm, divided by the length of our hypotenuse, which is 5 cm, right? So we can simplify this. Sine 45 degrees. We have cm in our numerator and cm in our denominator, so they can cancel. We have x over 5. Well, similar to the example above, we want to find our unknown variable x. So we need to get rid of this 5 in our denominator and put it over the equal sign, which means it becomes a product. So we have 5 times sine 45 degrees is equal to x. I can rewrite my equation. X is equal to 5 times sine 45 degrees. Of course, that is equal to cm when we get our final answer, right? So you jump into your scientific calculator and you do 5 times sine 45 degrees, right? And we get x is equal to 3.53553 cm. Of course, we need to put this answer to 3 significant figures. So therefore, x is equal to 3.54 centimeters. Of course, that 5 here is 5 or greater, so we increase the significant figure to the left of the side by 1, so we get a 4. All right, and of course we must put down our answer to 3 sig figs, and that is my answer. Moving on. Next example. So here we want to identify our angle theta, that is equal to x, right? Let me just identify it here, right? That's our angle. We also know that the side opposite this angle is given to us, and that side is our opposite of cos, and it is equal to 4 cm. We're also given the side that is opposite our right angle, and that side is our hypotenuse, and it is equal to 5 cm. Well, we know our angle, it's our unknown, that's what we want to find, and we also know our opposite and our hypotenuse. Well, let's put down our acronym: SOHCAHTOA. All right, so we know for sine we need our opposite and hypotenuse, and that's exactly what we have. So we will be using sine again for this example. So sine theta is equal to the length of our opposite divided by the length of our hypotenuse. So we can just jump right in there. Sine x, that's our angle, x is our unknown, is equal to the length of our opposite, 4 cm, divided by the length of our hypotenuse, 5 cm. Let's simplify this. Sine x is equal to, we have cm in our numerator and cm in our denominator. They can cancel each other, and that is equal to 4 over 5. We are at a point where we want to find x, and we are applying the trigonometric function sine to x. We need to get x alone on one side of the equal sign. In this example here, it's going to be the left, right? So we have to transpose our trig function sine. Whenever you're taking a trig function and you bring it and you're moving it or transposing it to the other side of the equal sign, it becomes the inverse. So x is equal to sine inverse, and we have our 4 over 5. So in your calculator, you can get that inverse by doing either a shift function, or I think some calculators call it a second function. All right, just look above your sine button, you will see the sine inverse, and above the cos button is your cos inverse, and above your tan button there's a tan inverse there, right? So all you need to do is press your shift and your sine button, you get your sine inverse function, and then you just put your 4 over 5 and you find sine inverse of 4 and 5, and I get x is equal to 53.13010 degrees. Of course, we will be putting this answer to 3 significant figures. Therefore, x is equal to 53.1 degrees, and that's the 3 sig figs, and that's my answer. Next example. Right, so let's start identifying our sides. We are given our angle theta, that is equal to 40 degrees. Okay, the side, wow, that is opposite our right angle, there is given to us as our hypotenuse, right? And our hypotenuse h, sorry, let's get this right, h is equal to 15 cm. We also know the side that the angle sits on, or better known as the adjacent. So we know A is equal to Y. Of course, that's what we want to find, right? So let's put down our acronym: SOHCAHTOA. So in order for me to use sine, I must know the opposite and the hypotenuse, and clearly I don't know the opposite, so I can't use sine. In order for me to use cos, I must know my adjacent and my hypotenuse, and it just so happened that, well, the adjacent is the unknown, but I know my hypotenuse, so the trigonometric function for this question here will be cos. And what do we know? Well, we know cos the angle or cos theta is equal to the adjacent, capital A, the length of the adjacent divided by the length of the hypotenuse, capital H. Right? So let's plug in our values. Cos the angle, which is 40 degrees, is equal to y, which is the length of our adjacent, divided by 15 cm. Right? So we want to find y. So we need to transpose or get rid of this 15 cm in our denominator, and we want to bring it to the other side of the equal sign, so it becomes a product. So we get 15 times cos 40 degrees, this is of course in cm, is equal to y. I can rewrite my equation. Y is equal to 15 times cos 40 degrees, and that is in cm. So I go into my scientific calculator, I do 15 times cos 40 degrees, and I get y is equal to 11.49066 cm. Let's write this cm a little better. Centimeters, right? So I'm going to put this answer to 3 sig fig. So therefore, y is equal to 11.5 centimeters. All right, and that is my answer to 3 sig figs. Next example. Right, so here we're dealing with a worded question. So example 3. In triangle PQR, angle PQR is equal to 90 degrees, angle QRP is equal to 41 degrees, and length PR is equal to 30 cm. Find QR. So we have a worded question. Where exactly do we start? Well, we know our triangle must be a right angle triangle, so we can just draw a right angle triangle. Wow, that's not my best. Let's do a better one. Let's draw a nice right angle triangle. Let's get it right. Oops, struggling. Okay, that's good, right? So for our right angle triangle, we know that angle PQR is 90 degrees. Well, our 90 degrees must be formed here. What does that tell us? It tells us that whenever we write angles, the angle sits on the corner. That's the middle. For triangles, the angle sits on the point in the middle. What does that mean? So angle PQR, Q, the point Q is where our 90 degree is. So this is P, because this is the point P, and this is Q, and this is R. So P, let me use a different color here. So PQR, angle PQR is 90 degrees. So the point Q is where our 90 degree is, right? So angle QRP, similarly, here the point R is where our angle is. So that angle is 41 degrees right here. All right, because we have Q, R, P. R is where our angle is, right? That's the point where our angle is. Good. So let's move on. We also have a length. PR is equal to 30 cm. So PR, and we can see here PR is the side that is opposite our right angle, right? So that side is 30. 1 second. So that side is 30 cm. Find QR, and QR, let's give it a symbol X, right? An unknown variable X. So we've been finding for X, and QR is of course the side that the angle sits on. So what do we know? Well, we know our angle is 41 degrees. We know our hypotenuse, that is equal to 30 cm. And we know that the adjacent, right, because the angle sits on that side, that is equal to that is equal to x, what we want to find. Remember our acronym, SOHCAHTOA, right? And here I want to find my adjacent. I have my angle and I have my hypotenuse. I'm not going to waste time going through all three. We've done that before. I know that I'll be using, let me get a different color. I'll be using cos. Why? Because I need to know my adjacent and I have my hypotenuse, right? So what do we say? We say cos theta is equal to the adjacent over the hypotenuse. Cos, we know the angle, that is equal to 41 degrees. Our adjacent, which is x, divided by our hypotenuse, which is 30 cm. I want to get x to be my subject of formula, so I need to get 30 cm on the other side of my equal sign. I know 30 times cos 41 degrees, cm of course, is equal to x. I can rewrite my equation. X is equal to 30 times cos 41 degrees. I go into my scientific calculator. I put 30 times cos of 41 and I get x is equal to 22.6412.9, and that is in cm. I'll be putting my answer to 3 sig figs, therefore x is equal to 22.6 cm. That answer is to 3 sig figs. Alright, that's my answer. Moving on. Example 4. We have another worded question right here. So it says, in triangle ABC, angle BAC is equal to 90 degrees, BC is equal to 11 cm, and angle ABC is equal to 68 degrees. Find AC. Well, we know we're dealing with a right angle triangle, so our first step is to draw a right angle triangle. Right, so let's get one looking like one that stands up, right? So here, my right angle is this corner right here, and I know that it's labeled A because angle BAC is equal to 90 degrees, right? So angle BAC is equal to 90 degrees. They told us that BC is equal to 11 cm. BC is our hypotenuse. How do I know this? Because it's the side opposite our right angle. BC is 11 cm. And angle ABC is 68 degrees right here. Alright. Should have drawn that bigger. No, that's good. Let's go. Right, so we need to find AC. Let's use a different letter this time. Let's use Y. All right. So what do we know? Well, we know our angle is 68 degrees, right? We know our hypotenuse because we identified that. That's the side opposite the right angle. That is equal to 11 cm. What do I notice? We want to find AC. AC is actually opposite the angle. So we know our opposite, and that is equal to Y. What we want to find? Well, remember our acronym, SOHCAHTOA, SOHCAHTOA. Right? What do we know? Well, we know our opposite, we know our hypotenuse, and of course we use sine for us to find our unknown. Okay, so sine the angle is equal to the opposite over the hypotenuse. So sine 68 degrees is equal to Y divided by 11 cm. I want to make Y my subject, so of course I'm getting 11 cm from the denominator and bring it over to the other side of the equal sign. So Y is equal to 11 times sine 68 degrees. and that is in cm. Put our brackets, right? I mean, I skip a couple steps. Let me not skip steps. Let's do this how I usually do this, right? Let's not skip steps. Okay, so we have 11 times sine 68 degrees is equal to, as in cm, is equal to y. I can rewrite my formula as y is equal to 11 times sine 68 degrees cm, right? So I go into my calculator, of course, and I do 11 times sine 68, and I get y is equal to 10.19902 cm. So our answer, therefore, y is equal to 10.2 cm. That's of course the 3 sig figs, and that is my answer. All right, and our last example, example 5. From this diagram, calculate A, the length of C, the length of CD. Right? Let's identify where our length is. So we want to identify the length of CD. That's that length right here. All right. So we know where our angle is. Of course, this is we have a larger triangle, ACB. All right, and we can see that it's made up of two right angle triangles. If I put my 90 degree here, because this line CD forms a right angle with line DB. All right, so let's pull out that triangle that we will be dealing with. Let me do this a little better. Right, thank you. Right, so we have our right angle here. No, this is too small. Let's get this bigger. Yeah, this is good for now. Okay, so we have our right angle here. We have D, we have A, we have C. We have our angle, which is 37 degrees. Our hypotenuse is 7.5 cm. How do I know it's the hypotenuse, right? It's the side opposite my right angle right here. Right, that side opposite, that is our hypotenuse. Okay, and we want to find CD. Let's give this the letter M. I don't know, let's use M, right? So what do we know? Well, we know our angle, that is 37 degrees. We know our hypotenuse, that is 7.5 cm. And we want to find the side that the angle sits on. This is better known as the adjacent. This is M. If you remember our acronym, SOHCAHTOA. All right, so we have our adjacent and our hypotenuse. We'll be using cos, right? So cos theta is equal to the adjacent over the hypotenuse. Cos, the angle is 37 degrees, is equal to our adjacent, our unknown M, over our hypotenuse, which is 7.5 cm. Right, so I need M to be my subject, so I have 7.5 times cos 37 degrees. Cm, of course, is equal to M. Rewrite my formula. M is equal to 7.5 times cos 37 degrees cm. I pull up my calculator. 7.5 times cos 37 degrees and I get M is equal to 5.98977, and that's in centimeters. All right, so my answer therefore M is equal to 5.99 cm, and that answer is the 3 sig figs. Remember, this is the answer for part A. All right, so the length of CD is equal to 5. Oh, that looks really dark. Let me use a different color font. Let me try the white. So this is 5.99 cm. All right, and of course we have a part B. So let me just clear this up. The beauty about trig ratios is that once you get the hang of it, you become a master. You won't even need to be thinking about your acronym anymore. So part B, the angle DCB. So they want us to find DCB. Remember that the angle sits on the middle side, or sorry, the middle corner. So DCB, our angle is at C, right? So let's give this angle the letter, let's use R, right? Let's use R. Blue looks pretty tough. Let me use the white. Let's use R, right? So we want to find angle DCB. Well, let's pull out that triangle, right? So we have, okay, that's good enough. So we have D, sorry. So we have DCB. Our right angle is on corner D. All right, and our angle, what we want to find is R right here. We know CD is equal to 5.99 cm, and we know CB is 12 cm. Well, I know CB, of course, that's the side opposite my right angle, so that is my hypotenuse. So my angle, of course, my angle is R, my hypotenuse is 12 cm, and of course the side that the angle sits on and right next to, that's equal to the adjacent. So we have 5.99 cm. All right, so let's use our acronym SOH CAH TOA. I have my adjacent and I have my hypotenuse, so I'll be using cos, right? So cos theta is equal to the adjacent over the hypotenuse. Cos the angle, of course, which is equal to R, is equal to the adjacent, which is 5.99 cm, divided by 12 cm. Let me get this out of here. Right? So I can simplify this. Cos R, cm in my numerator, cm in my denominator, 5.99 divided by 12. I want to get R as my similar formula, so I need to get cos on the other side of the equal sign. Remember, if you're taking any trig function and you put it on the other side of the equal sign, it becomes its inverse. So R is equal to cos inverse 5.99 over 12. All right. Of course, that will give you your answer in degrees. So go to your calculator. Remember, do your shift or your second function to get your cos inverse, and then you do 5.99 divided by 12, and you find your cos inverse of that. And I got R is equal to 60.05512 degrees, Of course, we'll be putting this thing to three significant figures, so therefore r is equal to 60.1. Let me write this better. R is equal to 60.1 degrees. That's a 3 sig figs, and that is my answer. Well, this concludes our first live tutorial, alright, under the topic geometry and trigonometry, subtopic trigonometric ratios. I hope you were able to work all the questions along with me, and if not, remember you can rewatch this tutorial and practice the questions again and verify your answers with me. Keep practicing, and all the best. See you in the next one.